Our next problem is a problem related to the asymptotes of a hyperbola. We are given that C is the center of hyperbola x square by a square minus y square by b square equal to 1. Tangents at any point on this hyperbola meets the lines bx minus ay is equal to 0 and bx plus ay is equal to 0 in Q and R, and we need to find the value of CQ into CR. Now for a hyperbola x square by a square minus y square by b square is equal to 1, the equations of asymptotes are y is equal to bx by a and y is equal to minus bx by a, and these are the two lines which are given in the equation. So let us proceed by making the figure first. This is the hyperbola. These are the two asymptotes for the hyperbola. This is y is equal to bx by a and this is y is equal to minus bx by a. Now if we make a tangent on any point P, it meets the asymptotes bx by a in Q and minus bx by a in R. So it is this triangle OQOR that we are talking about, QOR. Now any tangent for x square by a square minus y square by b square to 1 can be given by x1 by a square minus y1 by b square is equal to 1, where x1 comma y1 is the point at which the tangent is made. If point P x1 comma y1 is taken as a sec theta comma b tan theta, putting the value of x1 comma y1 in this equation, we have x sec theta by a minus y tan theta by b is equal to 1. This is the equation of this tangent. Solving this with the equation y is equal to bx by a, we have x sec theta by a minus bx by a into tan theta by a is equal to 1, or rather this is b. This b and b gets cancelled and we get x is equal to a upon sec theta minus tan theta, and y is given by bx by a, so y is equal to b upon sec theta minus tan theta. These are the coordinates for point Q. Similarly, solving the equation of tangent with the asymptote y is equal to minus bx by a, we get x as a upon sec theta plus tan theta and y as minus b upon sec theta plus tan theta. These are the coordinates for the point R. Now we need to find the value of CQ into CR, where C is the center for the hyperbola. So value of CQ becomes under root of a square plus b square upon sec theta minus tan theta, and the value of CR becomes under root of a square plus b square upon sec theta plus tan theta. When CQ is multiplied by CR, in the numerator we get a square plus b square, and in the denominator we get sec theta minus tan theta into sec theta plus tan theta, which is sec square theta minus tan square theta, that is 1, and hence the value of CQ into CR comes out to be equal to a square plus b square. In this question we learned one important thing, that the two asymptotes for any hyperbola x square by a square minus y square by b square equal to 1 is y is equal to bx by a and y is equal to minus bx by a. These are the two important formula for the asymptotes that you should remember, and hence the final answer for CQ into CR is a square plus b square.